Hello and welcome. I am Mr. Murphy, and in this particular video we're going to be looking at power standard number 17. Now this power standard builds off of the previous one, so if you have not watched and perfected power standard number 16, you want to make sure you do so before watching and attempting this video, because we're going to be, like I said, building and taking what we did in the previous video one step further. In this particular power standard we're going to be looking at, again, using the quadratic formula to find the solutions, the roots, the zeros to a quadratic equation. But the difference here is, in the previous one we were looking at situations where the square root part ended up in a rational answer, like square root of 81 was 9. But what happens if it doesn't work out that way? What if it turns out to be an irrational number, or a situation where it's going to be a non-real solution? Well, that's what this video is all about. So let's look at what I'm talking about here. First off, you should recognize this information, but just to review, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And remember that this formula finds the roots, the zeros, the x-intercepts of the parabola. All three of those mean the same thing. And also remember that we have to look for those two things. We have to look to see, is it in standard form, ax squared plus bx plus c? And secondly, is it equal to 0? If all those things are true, then we can go ahead and use that quadratic formula. But what if we start using the quadratic formula, and while doing so, we end up with a portion that's under the radical that looks like one of these two possible scenarios? Well, I'm going to be looking at how to solve these two roots first. So we're not using the quadratic formula right now. I'm just going to show you what would we do in these particular situations. And then in a minute we're going to look at a couple of examples where we would end up with solutions looking like this under the radical. So let's look at that first one there on the far left, the square root of 72. The square root of 72, if you type that in your calculator, you're going to end up as a decimal. And we want to leave these as exact solutions. We do not want to get decimal answers right now. So that's why we're going to look at how would we simplify this. Well, there's a couple of ways to do that. Different teachers teach it differently. Not to say that my way is the best way. It's just the one that I'm most comfortable with. It's one that I see that students are also most comfortable with as far as the way that I teach it. So let's look at this. The way that we're going to do this is using what's called a factor tree. So we're going to look at the square root of 72, and we're going to say, well, what two numbers, any two numbers that would multiply together to give me 72, as long as it's not 1 and 72, because we want to break this apart. So you could use, for example, 8 and 9. Or we could use 2 and 36, would have also worked. But let's just say we used 8 times 9. Well, neither of these are prime, so I need to take and factor these out as well. 8 breaks down to be 2 times 4. Now I'm going to circle 2 because 2 is a prime number, and you'll see why I circle that here in a minute. But 4 is not prime, so I need to factor that down further. 4 breaks down to be 2 times 2, and I circle those because those are also prime. Now I don't want to forget about this 9. That's one reason why I circle the numbers, is that helps me see that if it's not circled, I'm not done factoring it yet. So I go up to the 9, and 9 breaks down to be 3 times 3. And 3 is also a prime number. If you've forgotten what a prime number is, prime numbers are numbers where they can only be, the only numbers that will divide evenly into them are 1 in itself. So some of the first smaller prime numbers would be 2, 3, 5, 7, 11, and so on, 13, and so on. But these would be what we would call the prime factorization of 72. If I multiplied all 5 of these numbers together, they would give me, the product would end up being 72. Now what we do here is I look for every 2 of the same number, I get to factor 1 out, which means I get to take it out of the radical. So in other words, I have a pair of 2's here. So I'm going to take out a 2 from outside that radical. I have a pair of 3's as well. So I'm going to take out a 3 from the radical. We're going to end up multiplying the 2 and the 3 together. I have 1 left over. I have this 2 that's left over that I don't have anything to pair it up with. So that's going to remain under the radical. And so my answer here, the square root of 72, would end up being 6 times the square root of 2. Well, what if it's negative? You can never take the square root of a negative number. For example, the square root of negative 81 is not negative 9. So to do a simple, if you ever have a square root of a negative number, the first thing you have to do is take an I out, because your I is your imaginary number. And after we take the I out, it makes it so that negative 81 is now a positive 81. And now the square root of 81 would be 9, so this would end up being 9i. Now if you don't know what I just did here with imaginary numbers, you want to make sure that you talk to your teacher and make sure that you can review what imaginary number is. But in a nutshell, the letter I represents the square root of negative 1. And so that's why I did this. The square root of 81, negative 81 is the same as the square root of negative 1 times the square root of 81. So again, make sure that you talk to your teacher, make sure you figure out what that imaginary number is. I just went through this assuming that you would already know that. So let's look at this particular example. Here I have the square root of negative 150. We can never take the square root of a negative number. So I have to start out by, to make this positive, I'm going to start out by removing an I, so it's going to be I times the square root of a positive 150 now. And now we're going to do it just like we did in this previous example. I'm going to take and factor this down. I could say, well, 150 is the same as 15 times 10. 15 breaks down to be, or I'm sorry, yeah, 15 times 10. 15 breaks down to be 3 times 5. 3 and 5 are both prime. 10 breaks down to be 2 times 5, and those are also both prime. So now, to simplify this, for every 2 of the same number, I get to take one out. So square root of 5, or I have a pair of 5s here, so I'm going to take out a 5. Along with the I would be outside the radical. And the 3 and the 2, those are not the same number, so I just have to leave those inside the radical, so multiply those back together again. 3 times 2 is 6. So I end up with 5i times the square root of 6 is what the square root of negative 150 would simplify to be. So now let's take and look at this particular example. X squared plus x plus 11 equals 0. So I want to use the quadratic formula here. So it's already in standard form and set equal to 0. So my value for a in this case would be 1. My value for b in this case would also be 1. And my value for c would be a positive 11. So now when I go and plug these numbers into that quadratic formula, it's going to be x equals the opposite of b, so the opposite of 1 is a negative 1, plus or minus the square root of b squared, or 1 squared, minus 4 times a, which is 1, times c, which is 11. All that divided by 2a. So again, when we go to simplify this, under the radical here, I would have 1 squared, which is 1. 4 times 1, negative 4 times 1 is a negative 4, times 11 is a negative 44. So I'd have 1 minus 44, which is negative 43. Now this is a unique problem because 43 is a prime number. So for this one, all I have to do is take out, because I can't leave that as a square root of a negative 43, I have to take out an I. So this is going to be x equals negative 1 plus I times the square root of 43 divided by 2, and negative 1 minus, minus I times the square root of 43, all divided by 2. Now remember, again, I'm assuming you already have talked about this, but we want to have our answers in the form a plus bi. So we're going to take these two fractions and break them up into two pieces. So because sometimes we can simplify these further. So for this one, your answer would be x equals negative 1/2 plus square root of 43 divided by 2 times I. So what I did there is I took this piece and wrote it as a square root of 43 or divided by 2 times that I. But again, you don't want to forget that you're also dividing the negative 1 by 2 as well. So that's why we break this up into two pieces. So for this one, I'm going to have negative 1/2 as part of my answer. Break this up. The other part of my answer is going to be this minus square root of 43 over 2 times I. So that would be your answer. Okay, I want you guys to try the same thing on this particular example. 6x squared minus 12x plus 10. I want you to use the quadratic formula here and simplify it as much as you can. And make sure you put your answer in a plus bi form when you get a final answer, if you're using an imaginary number. So go ahead and try this on your own. Hit pause the video and hit play when you're ready to check your answer. Okay, so we should have found that your value for A is 6, B is a negative 12, and C is a positive 10, using the quadratic formula. Opposite of B would be a positive 12, plus or minus the square root of negative 12 squared minus 4 times A, which is 6, times C, which is 10. That whole thing divided by 2 times A, well, 2 times 6. We'll simplify that in a second. Okay, so let's see what we get underneath the radical. Negative 12, when you square that, is a positive 144. Negative 4 times 6 is negative 24. Times 10 is a negative 240. So I have 144 minus 240, which gives us an answer of negative 96. Okay, so now we have the situation. We have the square root of negative 96. We're going to end up having to take out an I here, because we're going to simplify that. Because the square root of 96 does not give us a nice little answer, it gives us a decimal, so that means it's an irrational number. So we need to simplify this root using the factor tree like we were doing in those previous examples. So square root of 96, well, 2 times 48 is 96, and 2 is a prime number. 48, again, you could break this down into any number of possibilities, but 6 times 8 is one possibility. You could have done 2 and 24. You could have done 3 and 16. You could have done 4 and 12. Or like I just did here, 6 or 8 would also multiply to be 48. So 6 breaks down to be 2 times 3. Those are both prime. 8 breaks down to be 2 times 4. 2 is prime, but 4 is not. 4 breaks down to be 2 times 2. So now for every 2 of the same number, I get to take 1 out. So here I have a pair of 2's. I'm going to take out a 2. I have another pair of 2's. Take out another 2, along with that I that we already took out. And the 2 times the 3, what's left over, we have to keep those under the radical, so they're going to remain under the radical. So 2 times 3 is 6. So square root of I times the square root of 96 would end up being 4I times the square root of 6. So that's what we have here. So I'm going to have x equals 12. We'll do this. 12 plus 4I times the square root of 6, all divided by 12. Or the other solution would be 12 minus 4I divided by, or 4I squared of 6, all divided by 12. Now we have to simplify both of these. We're going to break these up and remember a plus bi form. So I have to take 12 divided by 12, which is 1, plus, well, 4 twelfths reduces to 1/3. So I'm going to write this as, you can write it like this, I squared of 3 divided by, or I squared of 6 divided by 3, or you could have said square root of 6 divided by 3 times I would be another way to write it. Now, also make sure that you know we cannot take the square root of 6 divided by 3 and say it's a square root of 2. That square root of 6 is trapped under the radical, so it's stuck there. We can't do anything with it. The other portion we would have would be 12 divided by 12, which is, again, 1. But this time we'd have minus 4I squared of 6 would simplify to be I squared of 6 divided by 3. And there's your answer. Well, there you have it. That is power standard number 17 about, again, how to use a quadratic formula. I know it was a longer video than some of the other ones, but there's a lot to make sure that you understood as far as making sure you know how to simplify a radical and making sure you know what to do if you have the square root of a negative number. So hopefully you have a better understanding now of how to find or how to use the quadratic formula to find those roots when we're dealing with situations that are not going to end up with rational solutions. So with that, good luck.